good afternoon, good evening, depending on what time you're watching this video. I'm Oboriti Namarin. I'm going to give you an overview about the local search algorithms, adversary search, and adversary machine learning. So, well, the local search algorithms we have in AI, we have hill climbing, which is a straightforward type of algorithm. Well, it looks at the shortest or the quickest solution to a problem. An example, we can have the shortest path for food delivery. Then we have simulated annealing. It allows algorithm to accept worse solutions to avoid local optima. An example, we can have the school timetable scheduling, whereby a teacher or a lecturer cannot be allocated to classes to teach at the same time. And we also have genetic algorithms that looks at an approach using selection, crossover, and mutation. An example, we can have the distribution of relief items after disaster. You have to select a certain group of people or select a certain area. We have improving usability with responsible and explainable AI. We have detailed explanations. You have to provide clear accounts of how solutions are reaching for auditing and stakeholder trust, ensure fairness, transparency, that is, explain decision making, explain why this and this is happening in a certain way. We have real world applicability, make decision processes transparent. Then we have bias and error detection. So we can have a look at the adversary search in our daily life. Well, adversary search is a type of algorithm used in competitive environments. Now, for example, in game playing situations, the main goal of each agent is to maximize their own utility while minimizing the utility of its opponents. How it works, got from the goal of each agent. Each agent, of course, seeks to boost their utility while minimizing their loss. One agent's action impacts the outcomes and objectives of the other agents. Scenarios where adversary search is applied, we can have bargaining for product in a winner market, competitive game in checkers, poker. And then let's go into minimax and expect minimax algorithm. Well, the minimax algorithm is a decision rule used for minimizing the possible losses in a worst case scenario. Both players are taking turns in making decisions. Then expecting minimax algorithm is an extension of minimax. It's used when the game of two opposing players has an element of chance. We can go deep into the alpha beta pruning technique. Well, alpha beta pruning technique is still related to the minimax and expecting minimax algorithm. It looks at a technique used to optimize a minimax algorithm. Well, its main purpose is to reduce the number of nodes elevated in a search tree, thereby speeding up decision-making process without affecting the final result. Key points we can take from the alpha beta pruning technique. The max player will only update the value of the alpha, then the min player updates the value of the beta. While backtracking the tree, the node values will be passed to upper nodes instead of values of alpha and beta. Then we only pass the alpha beta values to the child nodes. That being said, we can now look at the concept of adversary machine learning. Well, it's a field of study focused on how machine learning models can be exploited or tricked by adversaries to produce incorrect or unintended outputs. Well, the components are an example. We can have the adversary attacks and adversary examples. An example I can give is, let's say we are using ChatGPT. I use twist a question in a certain way. ChatGPT has been trained to produce certain answers. Of course, it does not know if this is correct or this is wrong, so it will just produce an answer according to how it has received that question. So to the user, it could be a wrong answer or a correct answer. So defense mechanisms in AML, we have the adversary training, defensive distillation, granite masking, input sanitation. Then the challenges and implementations, we can have transparency, real-world impact, defending against the unknown. Then the relationship between AML and adversary search. Well, these two are greatly related, but they have some areas whereby they differ. They're related in the strategic opposition, optimization, and counter-reaction, prediction of adversarial behavior. Then non-cooperative environments, those are areas whereby they're related. Then they can define their objectives, methodologies, and contexts, as we have seen. Well, thank you very much.